Okay, so we're picking up with section 1.2 where we left off, and now we're moving from looking more visually at the graph to a little bit more algebraically, symbolically. Okay, so we have a definition which states that an x-intercept of a function f of x is a point on the graph where y equals 0. So an x-intercept is when y equals 0, and that will be where the graph intercepts the x-axis. And similarly, a y-intercept of a function is a point when x equals 0. Okay, and Theorem 4 states that a value r is a 0 of a function f if and only if f of r equals 0. So what this is saying is that the 0 is another word for the x-intercept. Okay, sometimes instead of giving the entire point for the x-intercept, we only give the x-coordinate because we already know that y equals 0. So you just have to pay attention to that from the context. All right, let's see an example. So for the entire problem number 3, we're dealing with the function f of x equals x cubed plus 1. Okay, so we're going to remember this equation. And then part A, it asks us, is the point negative 1, 2 on the graph of x? So this is asking, when x equals negative 1, does y equal 2? So I'm just going to plug negative 1 in and see if I get 2 out or not. So we know that f of negative 1, that means that everywhere we see the x, we replace it with negative 1. So f of negative 1 is negative 1 cubed plus 1. Negative 1 cubed, it's negative 1 times negative 1 times negative 1. So totally that's negative 1. So this is negative 1 plus 1, which is 0. So because f of negative 1 equals 0, not 2, so 0 doesn't equal 2, so then we can say no. That point is not on the graph of the function. Okay, so then I'm just going to write down here the fact that f of x equals x cubed plus 1 so that we remember. And this is the continuation. I'm sorry, I skipped part B. So for part B, it asks if x is equal to 3, what is f of x? And therefore, what point is on the graph of f? So if x is equal to 3, then f of 3 is equal to 3 cubed plus 1. And 3 cubed is 27. So 27 plus 1, which is 28. And then, so from there, we can say that the point 3, 28, is on the graph of f. Okay. So similar problem in part C, but a little different. Because in part C it says if f of x equals 1, what is x? What point is on the graph? So in part B, you are given x, but in part C, you're given y. So what that means is that 1 equals x cubed plus 1, and then we need to solve this one for x. So I'm going to subtract 1 to both sides, and then I would have 0 equals x cubed, and then I will take the cube root to both sides. So x will equal 0, okay? So the point on the graph is when x is equal to 0 and y is equal to 1. Okay. So for part D, we're asked about what's the domain of f. Remember, the domain is all of the x values that you can plug in the function. And I recommend, rather than thinking of every possibility, just think of anything as forbidden. Usually we need to look at denominators not being 0 or negative numbers being underneath the square roots. But this function, x cubed plus 1, it has no denominator and no square root, so we can say that the domain of f is all real numbers. I can cube any number, and I can add 1 to any number. Okay, so moving on to one of the new concepts, we're going to list the X intercepts, if any, of the graph. So remember from right up here that the X intercept is when y equals 0. Okay, so basically we just need to figure out what value of x makes y 0. Okay, so we set up the equation x cubed plus 1 equals 0. Like we did in part C, we subtract 1 to both sides, and then we take the cube root. Please note, it's fine to take the cube root of a negative because when you multiply a negative 3 times, it stays negative. And so I get x equals negative 1. So x equals negative 1 is the x-intercept, or I can say that the point negative 1, 0 is the x-intercept. And then similarly, finding the y-intercept means plugging in x equals 0. So I have to take 0 cubed plus 1, and I'm trying to find y now. Remember, y is the same as f of x. 0 cubed is 0, so this is equal to 0 plus 1, which is 1. So the y-intercept is 1. And in part G, it seems like a tricky question because it says what are the zeros of f? But remember, the zeros are the same as the x-intercepts. So since we already found the x-intercept in part E, we can just directly answer that x equals negative 1 is the 0. Okay, so these were all kind of like intermediate steps that we use. Partially it's good to review, but the main purpose of it is to figure out how to plot points in order to help you graph the function. So basically, like, based on what we did so far, let's see. I'm just trying to, so I know that when x is equal to 0, y is equal to 1, right? We already did that before, and then I also know that when x is equal to negative 1, y is equal to 0. So I don't have to redo that work, but then for like all of the other points, I don't think we did this one yet. So for example, if I take negative 2 cubed plus 1, that'll be negative 8 plus 1, so I can put negative 7 here, right? If I take 1/2 cubed, and if you're not sure, you can take it on your calculator. It's going to be for this part here, sorry, so this is going to be 1/2 cubed plus 1, which is going to be like, what, 1/8 plus 1, 1 1/8, or if you want it to be in a decimal, it would be like 1.125. So then we have that. If I take 1 in, I will have 1 cubed plus 1, which is 2. And if I take 2 in, I'll have 2 cubed plus 1, so that's 8 plus 1, which is 9. Okay, so from this table, I can make the graph. And so I'm going to have my x-axis and my y-axis, and I can see that y has to go down to negative 7 and up to 9. So I want to make sure that I have all those points. These are supposed to be evenly spaced out. My graph isn't perfect, but it's good enough. Okay, so always showing the scale on your axis, excuse me. And then for the x values, I only went between negative 2 and 2. So I will probably make it look something like this. Okay. So I'm going to plot the points in my table. So when x is equal to negative 2, y equals negative 7. Okay, so that's like a little bit beneath of negative 6. And then when x is equal to negative 1, y is 0. When x equals 1/2, and it's always good to have some negatives and some fractions to get your graph looking more accurate. Y is equal to 1.125. Oops, I'm sorry. I have to put it here. And then when x equals 0, y equals 1. And then when x is equal to 1, y is 2. And when x is equal to 2, y is equal to 9. So something like this. So we imagine the graph maybe looks something like that. This is like my terrible picture with the connected dots on my stylus. This isn't exactly perfect, okay, but it's approximately what the graph looks like. So you can always get an approximation of the graph by plotting points, okay? So we can also use the graph to find the range. So the range is all the y values that have an x value. So the range is all real numbers. The graph is nice for finding the range because it can actually be difficult to find the range just from the equation, but it's not as bad to find it from the graph. Okay, so let's do this example. So this is like a similar example, but basically all of the baby steps are removed. We're going to graph y equals 2x plus 4 and find both the domain and the range. So I'm going to do a similar thing where I make a table of x's and y's. Okay, so let me take -2, -1, 0. Maybe I'll take a half, 1, and 2. Okay, so we'll start with this, and then hopefully we can connect the dots to get a decent picture. If not, we have to do it a little more specific. Okay, so like I'll show you what I'm doing for my work here. So I have to do 2 times x plus 4 every time, and this time x is -2. So 2 times -2 is -4, plus 4 is 0, right? Okay, so I think I can kind of just keep this as my scratch paper, and then you don't need to see every detail. So for this one, we're going to do 2 times -1 plus 4. So that's -2 plus 4, which is 2, okay? And then so forth. So the next one we'll have 2 times 0 plus 4, which is 4. If you aren't sure about the fraction one, we can always do it the long way. So 2 times 1/2 plus 4 is 1 plus 4, which is 5, right? Next we'll have 2 times 1 plus 4, which is 6, and then 2 times 2 plus 4, which is 8. Okay, so we're going to try to make the graph now. So here's x and y. I need y to go up to 8. So let's count maybe by 2. So 2, 4, 6, 8. And then for x, I can just count by 1s because that's how I chose it. So I know that when x is -2, y is 0. When x is -1, y is 2. When x is 0, y is 4. When x is 1/2, y is 5. And then we have 1, 6, and 2, 8. Okay, so basically the sketch is something like this. So it's actually a straight line, but like I have trouble drawing freehand on the stylus, and this is just a sketch. So this is what we think the graph of y equals 2x plus 4 looks like. And based on this, we can see that both the domain and the range are all real numbers. There's no problem. Domain is range is all real numbers on this problem. Okay, so I'll pause this, and then in the last video, we're just going to see some real-life examples of functions.